Right, the next level with radicals is being able to add and subtract them. Simplifying radicals is never going to escape you. Okay, that is going to be a skill that you need throughout this radicals unit. When we add and subtract radicals, there are a few rules that you need to be aware of. The first rule is that when we add or subtract two radicals, you must simplify the radicand first. Well, what is the radicand? Let's remind ourselves. Okay, in this expression, 3 square roots of 5, 5 is the radicand. Remember, the radicand is that number under the house. Okay, the radicand is the number under the house. So throughout these notes, throughout this task, we're going to continue to come back to this example. Okay, we're going to follow rule number 1 first. Okay, we have to simplify the radicand first. So let's talk about some prime numbers that can go into 180. I know 2 and 90 can, but is 90 a perfect square? No. I know that 3 and 60 can, but is 60 a perfect square? No. I know 5 can, and 5 is going to go into 18 3 times, with 3 left over, 36. Is 36 on your list of perfect squares? The answer is yes. So I know that this can be broken down into 36 times 5. But what's the square root of 36? 6. So down here at the bottom, I'm going to write 6 square roots of 5. Remember that perfect square root comes out. The imperfect thing stays inside the house. Same thing we need to simplify in number 3. In number 3, I know I have 2 and 10. I have 4 and 5. Okay, those are the factors of 20. Well, 4 is a perfect square. So I know that this is going to be 4 times 5. And I know that the square root of 4 is 2. Now, this note here tells us to not forget about the 7. When I bring this 2 out, what am I going to do with that coefficient of 7? You're going to multiply it. Okay. So 2 times 7 is 14, and this becomes 14 square roots of 5. Okay. Again, rule number 1, we had to find the most simplest form of that radicand. Rule number 2. Okay. In order to add or subtract two radicands, they must have the same radicand. So this is similar to adding two like terms. Okay. So with the rewritten expression in number 4, they should have produced the same radicand. They did. Here, number 4, they have the same number underneath the house. They're both 5s. So these two radicands could be added. What is the new radicand they have in common? Well, the number they have in common is 5. Okay, the square root of 5 is their like term. Okay, so I'm going to rewrite this and say 6 square roots of 5 plus 14 square roots of 5. Okay, and I'm going to relate this to something that you're used to seeing a little bit more. You're used to seeing something written as 6x plus 14x. Okay, and we know your like term is the x and the x. So what would you tell me this answer is? 16 plus 4 is 20. This is 20x. And you'd say, this is my final answer, Miss Walsh. The same thing works when you've noticed you have the same radicand. When you have the same radicand, all you are doing is adding the coefficients. So this final answer is going to be 20 square roots of 5. Okay. But in order for that to happen, we had to have the like terms. So we're going to look at 6 through 9 down here. And I actually want you to pause the video and take a moment to see if you can figure out which radicals can be added or which ones can be not. When we add like radicands, okay, they have to have the same number underneath the house. So if I look at 2 and if I look at 3, are those numbers the same? No. So no, we cannot add these. They do not have the same radicand. What about a number 7? 5 and 5. Those are the same, so yes, we could add those if we wanted to. What about 7 and 6? Are those numbers underneath the house the same? No, so we cannot add them. And our last example here, number 9, 11 and 11. Those are the same, so yes, we could add those and simplify that expression. Okay. So to recap this page, rule number 1, you must simplify. Rule number 2, after you simplify, you're searching for the same radicand. Let's flip this page over. Rule number 3, I kind of added into rule number 2. If you have the same radicand, you are only going to add the coefficients. If you have the same radicand, you are only going to add the coefficients. So let's go back to question number 4. That was 6 square roots of 5 plus 14 square roots of 5. Again, we have the same number underneath the house. So this is going to become 20 square roots of 5. And this is our final answer. Okay. Now we're going to follow all 3 rules in order to simplify the expression. Okay, we're going to try these 3 to simplify the expression. So, rule number 1, we want to check to make sure that these are actually simplified as possible. 15. Is there anything perfect about 15? No. So rule number 1 is taken care of. Is 15 and 15 the same number underneath the house? Yes. That's rule number 2. Rule number 3, add the coefficients. So I'm going to add 2 and 7 to get 9 square roots of 15. Let's look at 12. The first rule is to make sure the number underneath the house, the radicand, is as simplified as possible. 3 and 27. 3 is simplified as possible, but is 27? No. How many times can 3 go into 27? 9 times. 9 is my perfect square. So this is going to work out. So I'm going to simplify. The square root of 9 is 3. So I'm going to bring that out front. 3 times a negative 4 is a negative 12. And that 3 is imperfect. It stays inside the house. Now I'm going to drop this other one, 20 square roots of 3. All right, rule number 1, simplify. We did that. Rule number 2, check to see if they have the same number underneath the house. They do. Rule number 3, add the coefficients. So what is 20 minus 12? It is 8. 8 square roots of 3 is going to be this final answer. Last example, let's look at our steps again. Step number 1, we want to simplify the radicand as much as possible. 2 goes into 8 4 times. 4 is perfect. That's great. Okay. 44, I just know my facts. This is going to be 11 times 4. And 4 is also perfect. Okay. So let's continue to simplify. The square root of 4 is 2. I'm going to bring that out front. The square root of 4 is 2. I'm going to bring that one out front. 2 times 17 is 34. Square roots of 2. 2 times 5 is 10. Square roots of 11 is what's left over. So we've done rule number 1. We've simplified. Let's do rule number 2. Do they have the same number underneath the radicand? No. The same number is not underneath the house. Those radicands are not the same. So we're going to stop and say that this is our final answer. Let's recap these steps and try a few more problems on our own. All right, to recap these steps, in order to add two monomials, the monomials must be like terms. So similarly, when we add two radicals, the radicals must have the same radicand. That's going to be our like terms. When adding two monomials, you only add the coefficients. Okay? Same rules apply when you add radicals. The most important thing that you want to reiterate in your head and go over again are each of these rules. You want to ask yourselves these questions each time you attack a problem. Is it simplified? Look at the underlined parts. Are they the same? If they're the same, you can add them. Okay. I want you to take these notes and these examples, and I want you to try these bottom three. Can you simplify? Can you identify that they have the same radicand? And if they have the same radicand, can you add to simplify?